sometimes. Okay, so here's my question. And I'm going to use the words that will trigger your answer, I hope. For every input, for every x value, I get a new output. So what is this then? How do we call it? If for every input I get a new answer.
It's just a function.
Thank you very much. Who said that? Josh? Thank you. So this is a function, yes? Was it Josh?
Yeah.
Given in a form of an integral. We cannot evaluate the integral. We will never be asked to evaluate the integral. We will be asked to find the derivative of that. So because it's a function, I will no longer call it a. I will call it f of x. Exactly. So the function is f of x because it's a function. It's the integral from a to x from f of t dt. It is even better not to use f. I'm going to use g because it's confusing. So I'm going to use g. It doesn't matter how we call it, but let's call it something else, not f. So we created a function called g of x that is a function given in the form of an integral. We will only be asked to find g prime. We will not be asked to find anything else. All I have to do is differentiate both sides and get g prime. And based on what we just discussed here, what do you think the answer is?
The f of t dt.
So when I differentiate an integral, these go away, and all I get is f of x. And that's fundamental theorem of calculus part 1. To show that when we differentiate an integral, we get the function. Let's look at how this works in applications. I'm going to share my screen. And this is in 5.3. Let's take a look. Okay. Nine through 20, use part 1 of the fundamental theorem of calculus to find the derivative of this function. So 9 through 20, you choose. And then we move on to 21 through 24.
About 17.
17 it is. Good, let me copy it and I'll stop sharing. So 17. Y equals the integral from 1 through 3x plus 2 t over 1 plus t to the third dt. Perfect. Perfect pick. So I'm going to go back to the fundamental theorem of calculus part 1 to explain or emphasize a few things. Notice that this is a number. Any number, we don't care, but it must be a number. Notice that the upper limit is x, or a function of x. So if this is x, this is x. But if I have w here, then I have w here. It doesn't matter. The variable is not important. But what happens if I have a function of x? Then if I have g of x as the integral from a, let's say, to a function of x, f of t dt, then g prime will be f of t, f of x, of course, but multiplied by this function prime. I would have written here x prime, because that's what I have at the top. But x, I didn't have to, because that's 1. But if there is any function up here, then I have to multiply by the inner function prime. This is the inner function, and this is the outer function. So I have to multiply by the inner function prime. Good. Since we already...
So are you supposed to take the first derivative of it when you simplify it?
I'll show you in a minute.
Okay.
So, remember, we are only asked to find the derivative. We cannot calculate this. This is a function, right? So we are only asked to find its derivative. So I differentiate the left-hand side and I differentiate the right-hand side as long as I have a constant here, which I do, and I have x or a function of x up here, which I do. So then, this will replace t everywhere, because it's not x. If I had x, I would replace t by just x. So I have 3x plus 2 at the top, 1 plus 3x plus 2 to the third, multiplied by, I don't know why I'm losing my voice tonight, the inner function prime. How much is the inner function prime?
3.
That's it. So this is 3x plus 2 over 1 plus 3x plus 2 to the third. We are only showing that the differentiation and integration are inverse operations. Next one, we need at least another one or two, maybe. Some of them are getting a little bit more complicated. In a moment, we're going to get to those examples. So anything else you would like to choose from these?
We try 18.
18 it is. So we have y equals the integral from 0 to tangent x e to negative t squared dt. Perfect. Set up, yes. A constant at the bottom, yes. A function at the top, or x, yes. Done. I don't need to rearrange, I don't need any preps. So when I differentiate the left-hand side and I differentiate the right-hand side. Can anyone give it a shot? Don't be shy, it's okay. Anyone?
It's going to be e to the negative tangent squared
Excellent, perfect step.
times
E to negative tangent squared times secant squared x. That's it, done. Great job. Good. Now let's look at something more sophisticated. Like, this is part 2. We've done this, we can come back to it. I'm still working on part 1. We'll come back to all these again. You feel free to choose from any of these. We already looked at several of these problems last time. But what I want is this. 67 through 71, find the derivative of the function. Anything you'd like to look at. These are slightly more sophisticated than the previous examples, and I'd like you to choose one. It's only because they have some intermediate steps. Which one?
68.
68. 68, I'm just going to copy a g of x, the integral from 1 minus 2x to 1 plus 2x t sine t dt. Perfect, Vic. Thank you. Okay. This is not ready. It doesn't have a constant here. If it doesn't have a constant here, I cannot immediately differentiate. I have a problem now. But I know a property of the definite integral that says the integral from a to b from f of x dx is the integral from a to c from f of x dx plus the integral from c to b from f of x dx. In other words, I will break this interval somewhere in the middle. Or not. It doesn't have to be in the middle. Somewhere in between. So then this function will be written as the integral from 1 minus 2x to whatever you want. Put any number you can think of. It doesn't matter. As long as you start at the same point. Pick a number that you would like to put in there. It doesn't matter. Any number you want. 0 it is. If that's what you want. 0 it is. Perfect. So now I can differentiate because this is okay. It has a constant, that's a lower limit, and a function or x at the top limit. But I have a problem here. But the definite integral has another property. When I swap the limits of integration, what happens?
Does it make it negative?
Exactly. Now it is ready. So now I can differentiate both sides. I can differentiate g of x and I can differentiate this. Both integrals are ready for differentiation. They are functions in the form of an integral. So how do we write the first one? Anyone? Sarah?
Would it be negative and then parentheses 1 minus 2x?
Awesome.
And then sine 1
Yes.
minus 2x
Very good. Times.
times 2.
Careful.
Oh, negative 2.
Very good. Awesome. Very good. In the same way, great job. 1 plus 2x sine 1 plus 2x times the inner function, which is 2. Yeah, I can just rearrange it a little bit, put negative 2 and 2 in front, so this will change. 1 minus 2x sine 1 minus 2x, and then plus 2. 1 plus 2x sine 1 plus 2x. Well done. Now let's go back and see if you want to practice with anything else. If you do, it's fine. If you don't, we continue. So, let me know. Anything else? Or we can, yes?
Give numbers 70 a shot.
Yes, absolutely, 70. So for 70, we have f of x equals the integral from the square root of x to 2x arc tangent t dt. Perfect. Okay, so this isn't ready. It needs preps. What do we need to do first?
We need to get a constant.
Yes, so the integral from the square root of x to whatever you want from arc tangent t dt plus from the same, has to be the same number, to 2x from arc tangent t dt. This is okay, but this is not okay. One more step, using one more property of the definite integral, which will be very good, awesome, thank you. Again, this is all it's saying is that we can differentiate a function in the form of an integral to show that the integration and differentiation are inverse operations. We cannot be asked to do anything else. Okay, so let's differentiate. So what will we put in?
Square root of that.
Of 2x.
1 over 2 square root of x.
Very good. And plus arctangent 2x multiplied by
2.
That's it. That's all we need to do. Now, before we continue, please tell me if you feel like working on any of these integrals. We did a problem with an area together. We did one of these problems with last time with a definite integral. We picked from all these, but if you feel like picking more, we'll have more in section 5.5. But again, we did this problem. We did this problem. We did this problem last time. I think we did this. So feel free to choose if you want to. If not, we'll continue.
Can we do 34?
34. Where is 34? 34. 34. Yes, perfect. So let's look at 34. Let me copy it. So the integral from -5 to 5 from e dx. Perfect. And let me stop sharing. Good. So this is a constant, and we know that the constant goes outside. So the function must exist. So there is nothing else that could be there but 1. But there must be a function. If there is nothing else, it has to be 1. So this is e. Which function prime is 1? Anyone?
Just x.
Very good. From -5 to 5. Leave the constant outside, plug in 5, and subtract when you plug in -5, but that does this. So this is 10e. Good.